Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 41 from the Smith Organic Chemistry textbook. And this problem asks us to predict the product for 3 oxidations. So the first 2 are going to be oxidations using PCC or pyridinium chlorochromate. And the third one is going to be an oxidation using chromium trioxide, sulfuric acid, and water, which are going to generate what's known as Jones reagent or chromic acid. And so for A, it's a PCC oxidation of a secondary alcohol. And so our product, since it is a secondary alcohol, is going to be a ketone. So the ring is unaffected there. Nothing else is affected, and the secondary alcohol is oxidized up to a ketone. So similarly for B, we have an alcohol. This time it's a primary alcohol, and it is going to be oxidized to an aldehyde. So you should hopefully remember that is the utility of using PCC instead of like chromium trioxide as we're using in part C. PCC allows for the oxidation to stop at the aldehyde state. So we're going to get an aldehyde for part B. And then like I said, for part C, since we're not using PCC, since we're using chromium trioxide, sulfuric acid, and water, the result is going to be a carboxylic acid. So again, that's the utility of PCC. It allows a primary alcohol to be oxidized only to the aldehyde, whereas a straight chromium reagent, like we're using here in part C, is going to over-oxidize, you might call it, all the way to the carboxylic acid state. And indeed, that's what we see for our answer to part C. We have a carboxylic acid. And so that's how to approach this problem. This problem really just goes to show the utility of PCC versus chromium trioxide. And that's the answer to Chapter 12, problem number 41.